Good day, and welcome to our webcast, New Tools for Compliance, Pneumatic Conveying Systems and Industrial Vacuum Cleaning Systems, sponsored by VAC-U-MAX. I'm your moderator, Kevin Parker, and I'm happy to have you join today on behalf of Plant Engineering and CFE Media. To get the best results from the webcast platform, please make note of the following as you participate in today's event. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of your screen to bring up a list of system checks to make before escalating to an online technician. If you are experiencing issues with your slides or audio, please refresh your browser or click the Refresh Media button directly under the presenter's headshot. If you need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box on the left-hand side of your screen. You can use the Ask a Question box on the left-hand side of your screen to type questions for the speaker during the presentation for the live Q&A session at the end. You may ask questions at any time during the presentation. We'll get to as many as time allows. To download the presentation slides and certificate of completion, use the event resources on the left-hand side of your screen. You can download the presentation and certificate of completion until the conclusion of the webcast. The link will break when the webcast signs off. This webcast is being recorded, including the Q&A session. We'll post the archive on the Plant Engineering website in a few days, and we'll send you an email message with a link connecting directly to it after it is ready. Now we will hear from the sponsors of today's webcast, VAC-U-MAX. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned after the video for today's presentation.
VAC-U-MAX is a worldwide leader in the design and manufacture of bulk material handling systems and industrial vacuum cleaning systems for conveying, weighing, batching, and cleaning over 10,000 various powders and bulk materials. Founded in 1954, VAC-U-MAX is the pioneer in vacuum conveying, developing the first air-powered Venturi unit, advancing technologies for direct loading of vacuum-tolerant process equipment, and the first to design vertical wall tube hopper material receivers. Additionally, VAC-U-MAX developed the world's first air-powered industrial vacuum cleaner for high-volume recovery of many materials for operation only on compressed air. VAC-U-MAX experience in cleaning combustible dusts dates back over 60 years, and today VAC-U-MAX is considered a subject expert in the safe collection of combustible powders and pyrophoric materials. A UL-listed designer and fabricator of control panels for general purpose and hazardous locations, VAC-U-MAX control systems can be configured to control a wide range of systems. With a strong customer-centric focus at every step of the process, VAC-U-MAX is committed to developing process automation systems that satisfy the needs and expectations of our customers. Committed to continual improvement with quality policies, strategies, and quality systems communicated within our organization, VAC-U-MAX provides quality equipment to process industries worldwide.
Welcome back. I'm now happy to introduce today's speaker. David Kennedy is Business Development Manager at VAC-U-MAX. Mr. Kennedy's career at VAC-U-MAX spans 23 years, beginning as sales manager for VAC-U-MAX's Industrial Vacuum Cleaning Division, where he developed plant safety and OSHA regulation experience, focusing on plant and operator exposure to dust and combustible dust. Mr. Kennedy has an additional 14 years of global sales and systems application experience in conveying and filtration for the chemical, petrochemical, food, pet food, and other general manufacturing industries. As already mentioned, I'm Kevin Parker, webcast moderator on behalf of Plant Engineering. David, the floor is yours.
Thank you, Kevin. Thank you to Plant Engineering for allowing us to make this presentation. Good afternoon to everyone on the East Coast. Good morning to those still having some coffee this morning before lunch. The topic today is about new compliance tools using pneumatic conveying and industrial vacuum cleaning equipment. The new aspect of it is really the way that we look at these technologies. They've both been around for decades, maybe longer. Pneumatic conveying systems and vacuum cleaning systems are not new technologies, but there are ways that we can look at them today to make them new compliance tools to some. In the past, justification was primarily a functional one for the plant manager or the manufacturing end manager. Those reasons might be automating a process, or they may be to increase production, to move from, to scale up a production facility. But these are proven technologies. They're not new, they are new tools, but they are proven technologies. So they are safe and proven to use. I'll start off with a few definitions. We define, for the purposes of this presentation, pneumatic conveying technology as a vacuum process. In other words, we move bulk powder from point A to point B under negative pressure. There are positive pressure systems, but for the purposes of compliance, we're addressing vacuum conveying. You can see in the graphic there, material can be moved starting from rail car process all the way to through mixing and storage and packaging, all in an enclosed process, all be done by vacuum. We'll define industrial vacuum cleaning as the collection of debris from in-plant surfaces. I emphasize surfaces for the purposes of housekeeping, sanitation, and/or recycling. I emphasize surfaces because there is sometimes some confusion between vacuum cleaning and dust collection. Dust collection is the collection of debris that is generally airborne. It is ambient air or air from a process that contains dust. Vacuum cleaning is dust that has settled for the most part. You see in the graphics there a picture of an operator doing overhead cleaning on the left from a scissor lift, and then a classic central vacuum system on the right. Compliance comes in, I'll say, two flavors. Regulations and standards, which generally are covering employee health and safety. The most current regulations and topics of compliance do have to do with employee health and safety. Some organizations will refer to it as continuing operations. NFPA refers to it as mission continuity, meaning facilities need to be able to design their processes and their operations to be able to continue operations in the case of a hazard or an incident. Other regulations relate to the environment, air, water, ground. Those are the popular compliance topics these days. There are also self-imposed standards, I'll call them. They are corporate goals. And many large companies, even small companies these days, are developing positive programs that benefit their employees or will benefit environmental conservation. Also goals that will result in reducing costs of operation. The regulations and standards are generally government issued, U.S. federal government, some state. They are geared towards employee health and safety, continuing operations, and what I'll call the greater good, which would be larger environmental issues, water and air, which affect people outside of the plant environment. Regulations and standards are different. So again, trying to define the regulations and the difference with standards. Regulations are promulgated by entities that can also enforce the regulations. That can be in the way of penalties or cease and desist. So I've listed a couple of the top entities there. The FDA, Food and Drug Administration, OSHA, the EPA, UL, Underwriters Laboratories. Some of them, the acronyms are enough for everyone. But these entities are sort of self-policing. They have the ability to enforce their regulations. The Underwriters Laboratory deserves an asterisk, because Underwriters Laboratories does not have an enforcement method. However, in terms of electrical equipment in North America or in the United States, electrical equipment needs to bear the proper UL safety sticker and for certification as a safe appliance. But as an example of how they can enforce it, Underwriters Laboratory has recently started a brand protection team, which is seeking out counterfeit UL certification products that are coming into our country or being made here that are being falsely labeled with UL standards, and they are taking those people to the authorities. So Underwriters Laboratories has teeth, if you will, to go with their certifications. Standards, on the other side of the coin, are developed by subject matter experts, or some call them interested parties, but they define best practices, and enforcement of standards is by other generally regulatory organizations. So the NFPA, National Fire Protection Association, develops standards and best practices in their area, but their standards are referenced by OSHA, for example. If OSHA does an inspection and they find out that you violated an NFPA standard, then OSHA will do the enforcement. ANSI, NIOSH, which is a part of the CDC, the Center for Disease Control, they are organizations that develop standards. And again, they're referenced in regulations of other bodies. There are other organizations that are, I call them compliance influencers. And those can include wastewater treatment plants in local municipalities, FM, which is Factory Mutual, which is also an insurance company. FM has their own safety standards, and they insure larger companies. The local fire marshal may be influencing your operations as an authority having jurisdiction under the NFPA standards and local codes. This is a non-human influencer, but premiums, insurance premiums are a cost of doing business, and they can greatly influence a company's decision on how it operates. And if you're in the petrochemical industry, perhaps others, you may be familiar with the phrase that training is not a safety device. This is the attitude that instrumentation, monitoring, and equipment are your greatest, are the one thing that you can rely on that won't be subject to training and human error. So down in Houston neck of the woods, you'll hear training is not a safety device. In the corporate goals category, these are management issued and management enforced. Corporations make decisions that are in their personal interest, regardless of what their competitors are doing or regardless of outside influence. I would define a corporate goal as a positive program for employee welfare, environmental conservation, and cost reduction. Some of these corporate goals may exceed established standards or regulations. So if a company feels that OSHA's noise level standard is not good enough, then you may find that a company has a lower permissible noise level in their plant than what OSHA would state. Again, for the betterment of their employees. You may find that corporate goals extend beyond national borders, where most regulations are pertinent to American companies or Canadian companies. You may find that a multinational corporation will have to develop policies that they'll use in their plants all over the world. So an international plant, the country of that plant may not have the same noise level standards as we do in the States, but corporations will implement their corporate policy. Some corporate goals may vary over time, and they may vary or fluctuate based on social norms or consumer influence. I don't want to say that they are fads, but they do tend to be trends. Some companies like to set the trend, but they are self-imposed. Occasionally, corporate goals may depend on a subsidy from government, as in the use of ethanol products or solar energy in some locales. There is government support for these efforts, and the corporate goals will work well until the subsidy disappears. So those are the kind of goals that may change. Other goals may reduce the costs of operation, such as workmen's compensation costs, and we'll talk a little bit more about that. So now into the meat of the discussion. Pneumatic conveying systems and industrial vacuum cleaners, new tools for compliance. Standards, some of the standards that are the hot topics these days belong to NFPA. You'll see a list of them there. There are several that have to do with combustible dusts. 652, 654, 484, and 61 are all related to combustible dusts. There are standard 350, has to do with confined space. There's also standards for the wood processing and woodworking facilities, 664. There is, since we're getting into summertime, there is standard 1124, which has to do with fireworks and pyrotechnic manufacturing. So just about every industry has some NFPA protection. Some of the tools for compliance with NFPA, with pneumatic conveying systems in particular, in a vacuum mode, which we're talking about today, it's the preferred technology for transporting combustible dusts. And I will, the short answer to why it is that if there is a leak in a vacuum conveying system, it leaks inward. This would be compared to a positive pressure system that if there was a leak, you have quite a disturbance in the plant, and a combustible dust environment is created if you're transporting, for example, flour or sugar in a positive system. You'll have 1,000 pounds on the floor before anyone is able to catch up with it. Not to mention the dust that's in the air. Vacuum cleaning is a preferred technique for cleaning most combustible dusts. The reason for that is that they can be safely grounded and bonded. They are available in compressed air configurations instead of electrical power, making it conducive to a combustible dust environment. And there's an underlying goal there of eliminating compressed air blow-off. Compressed air increases the chances of combustion occurring with static electricity and finely divided dust in the air. So blowing dust up into the air is a no-no, specifically written in NFPA standards 654, 652. OSHA has standards that they are all-inclusive, if I could say so. They make cross-reference to all of the any applicable standard that they can find, and I say that respectfully. Combustible dust being the popular one, as I mentioned before, which includes process hazards analysis requirements and dust hazard analysis requirements. They are concerned about confined space, noise, fall hazards, slip and fall hazards, communicating with the people who are surrounded by these or working with these materials that are combustible. They listed ergonomics at the top, but in reality, there is no OSHA ergonomics standard by itself, as there is with combustible dust. Ergonomics, however, is cited under a general duty clause, which states that all employees have the right to a safe working environment. So OSHA inspectors will cite ergonomic failures, give citations for ergonomic problems under the general duty clause, which leaves a lot of room for the inspector's interpretation. I'll also point out that in the new federal budget, OSHA was given permission to increase its minimum fines to about $12,000. That's up from about $7,000. So you can see that serious fines are, the cost will escalate quickly. Pneumatic conveying as a compliance tool with OSHA. Generally, they are a lower noise level. If noise is a consideration in your job, then pneumatic conveying generally has a lower noise level than mechanical conveying equipment. Pneumatic conveying can eliminate lifting and pushing hazards. This is under the ergonomic category. It has the ability to lift materials to upper levels, mezzanines, without the use of ladders or overhead lifting hazards. And that would be under the fall and slip category. They also can reduce exposure of operators to the conveyed materials because everything is done through an enclosed process. And they are easy to static ground and protect from explosion. An example of a lifting hazard, a falling hazard. We actually received an inquiry today, and I'll read it from this unspecified customer. we need to find a way to get our dyes into our mixing tanks. As of now, we manually dump them into the tanks. The tanks are large, and this requires the operator to get the material on top of a catwalk. Then dump small containers into the tank, and the containers weigh about 55 to 60 pounds. We want to get away from handling the material as much as we do. That's a perfect opportunity for pneumatic conveying. On the vacuum cleaning compliance with OSHA, industrial equipment will replace shop vacs from a safety standpoint. If anybody's using shop vacs in a combustible dust environment, please cease and desist. Industrial vacuum cleaners are available with compressed air powered, as I mentioned before, and that provides an intrinsic safety factor since there's no heat, no electricity. So they are terrific for a combustible dust environment. Some industries require wet recovery of powders, of combustible powders, such as some of the metal powders. For example, in 3D printing, this is a new industry, the additive manufacturing industry. The metal powders used in that process, the machines, the 3D printers need to be vacuumed out after a part is built, and a wet recovery vacuum, or we call it a submerged recovery vacuum, is used for safely vacuuming metal powders that are combustible. Industrial vacuum cleaning also allows you to do overhead cleaning. This is where the finest dusts are found. The dust that floats in the air and lands on the beams inside your facility, the purlins, the tops of walls, tops of equipment. That's where the most combustible dust is located. And it will replace blow off of using compressed air guns. I jumped ahead on a slide here, but the FDA has the Food Safety Modernization Act, which actually goes to 2011 as an origin, and it applies to U.S. businesses that are either in the U.S. or any other country. So even overseas facilities of American companies are not immune to this new act, relatively new act. And anyone that is required to register with the FDA as a food facility. There is a Table 6 in that standard that talks about how you evaluate hazards in your plant. And you need to, the first item is reducing or eliminating physical hazards in the food product. This is control of your incoming product. If it's coming from another supplier, you have to validate their quality of supply. But once it is in your plant, if you can keep it in an enclosed process, such as a pneumatic conveying system, then you eliminate the opportunity for foreign material and or the human element to affect the material being moved. It is also, you also need to evaluate allergens, and this is another way pneumatic conveying is used, is to keep materials under control and separated in isolated areas which meet that hazard evaluation. And the equipment design needs to be easily cleaned. This pertains to, in the pneumatic conveying industry, this is relatively easy, in many cases quite easy, because the equipment can be disassembled without tools, and often in the food industry it's going to be stainless steel construction and can be polished, so that equipment is easily cleaned. Also, food grade equipment, pneumatic conveying equipment, eliminates any glued in gaskets, again making it easy to clean. An example of maybe existing technology in your plant would be an open conveyor belt transporting grain products or cocoa beans, things like that. Open screw conveyors are also used, although open today is probably screened, at least over the top. But they are opportunities for material, foreign material, undesirable material to get into the process. Compare this to a pneumatic conveying system, pictured on the left. Material coming out of that day bin enters a pickup point and goes in the silver cylinder in the bottom and enters a closed tubing network. And that material is untouched all the way until its destination, whether that's a mixer or a blender or a size reduction machine or weighing equipment. It's all done in an enclosed process. Picture in the upper right shows sanitary grade equipment handling capsules or tablets or powders for making tablets, and that equipment is polished and it is can be disassembled without tools. Again, no glued-in gaskets, can be disassembled in parts sizes that are suitable for manhandling. The Food and Safety Modernization Act, if you look at that graphic, this is back to the original graphic we started with, I thought it represented well that a pneumatic conveying system can provide an enclosed environment from the ingredient supply to the final process or product with components that are easily cleaned. So it is enclosed, it is productive, it is easily cleaned, not to mention they go around corners and changing in elevation a lot easier than a conveyor belt does, or a screw conveyor. So they follow tortuous paths a lot easier. Sustainability measures, these are corporate goals. Often they will be to eliminate or reduce landfill waste, to reduce lost product due to an inefficient process, or to reduce charges from local wastewater treatment facilities for BOD content. That one is I'll talk about that one in just a second. Some compliance examples. Under the OSHA and ergonomics subject, repetitive motion is a huge cost to industry. Musculoskeletal injuries from lifting, small bags, box dumping, or repetitive motions. Another example would be shoveling of high-density materials or large spills. If you happen to have a large spill in your plant or a piece of process equipment fails and needs to be emptied. Again, those are cited under a general duty clause. This picture in the next slide shows a vacuum conveyor on the top of that stack up, a flexible hose going into it from the front. That's the material feed. That process, maybe in prior days, may have been loaded by hand with workers climbing a ladder with a bag or a drum and dumping it into the process. Now it can be vacuumed from floor level up 10, 20, 30 feet vertically and discharged into a process. So that eliminates the ergonomic hazard of carrying materials, it eliminates the dust exposure when dumping materials, and it eliminates slip and fall hazards when climbing ladders or being at an elevated process where you may, because of the location off the ground, you may have to suit up the operators with harnesses for fall protection. This next slide shows one of those vacuum cleaning applications that may not be commonly known, that there are vacuums powerful enough to pick up powdered steel or abrasive, this is steel shot abrasive media, in a plant that manufactures steel beams. And that powder weighs about 250 pounds a cubic foot. So a 5-gallon pail might weigh 150 or 200 pounds. And that vacuum will, a vacuum cleaner, portable vacuum for that matter, can pick up that material at 6,000 pounds an hour, eliminating shoveling, brooming, and definite high potential for a back injury. If you look at some of the recent studies having to do with the cost of back injuries, you'll find numbers ranging between $40,000 and $60,000 as the average cost for a back injury, and that's a direct cost. There are some estimates that say between 6 and 20 times that cost are the indirect costs of a back injury. And because that back injury may have happened during a larger incident, there are training costs, replacement worker costs while that person is out, increased costs in workman's comp premiums. These can be huge numbers, and the avoidance of one back injury will pay for the cost of this equipment in this application. You could pay for the cost of it. It would have a return on investment of 4 to 6 months. Another hot topic these days is respirator fit programs. This is exposure to dusts, hazardous or non. In the industrial vacuum cleaning applications, you can eliminate, and you want to eliminate, compressed air blow-off and sweeping. This is specifically called out in the silica and combustible dust national emphasis programs from OSHA. So vacuum cleaning captures the dust instead of setting it loose. Using a vacuum cleaner will eliminate dust that is kicked up by forklift traffic. A study by a government entity having to do with sand and the silica in the foundry industry stated that dust kicked up by a forklift, this is silica dust, can remain suspended in the air for up to 7 days. So forklift traffic is a huge contributor to dust, fugitive dust, and dust inhalation hazards. Pneumatic conveying, which again by definition is an enclosed process. So it replaces fugitive dust that would typically emanate from material conveyors such as belts or screws. Pneumatic conveying can eliminate manual dumping, the ergonomic standard in the respirator, the respirable dust subject. One of the challenges with a respirator fit program is the constant monitoring costs and the requirements that operators remove any facial hair. And I visited a facility recently where the safety manager said, we either have to get a vacuum cleaner or you have to wear a respirator, in which case you have to shave your beard. And the operator said, I'll quit first. It's men and their facial hair. It's a sensitive subject. This picture, or two pictures, show a bag dump station. This would be a pickup point for a pneumatic conveying system, or it could be just a simple dumping process over a mixer, where bags previously were slit open and dumped with all of their wonderful fugitive dust in the dumping process, the mushroom cloud that accompanies it. A bag dump station, in these pictures, they have integral dust collectors. You can see the fan on top of the bag dump station on the left. There are filters in there, and whatever dust is captured is discharged back into the bag dump station, so it's not lost product, but it pulls it away from the operator's face. Another source of fugitive dust is that empty bag. He just slid open a 40-pound bag of a very light powder, a fumed silica, for example, and now he's going to flatten that bag, or somebody's going to flatten it before it's disposed, which again will launch more dust into the air. A bag compactor that's shown in the left-hand picture can be connected to a dust collector so that when the bag is compacted to reduce your waste, the dust that comes out of the bag is compacted. So if you have a bag dumping operation, just follow the operator for a few minutes and watch what happens with the empty bags. Picture on the right shows a vacuum lifter, that blue tube. So if you have a repetitive operation or your bags have a high density material, you may want to use a vacuum lifter to take bags off of a pallet to place them into the bag dump station. That eliminates the repetitive motion, the twisting and turning, and the lifting hazard that accompanies that operation. Also part of the respirator subject is the blow-off. Picture on the left shows a cement bulk tanker being loaded. After it's been loaded and they're blowing off the manhole covers. The picture on the right would be the preferred technique, having a vacuum cleaning system connected to that operator's, that platform where they can vacuum off the material rather than blow it into the atmosphere or into the surrounding ground space. The respirator fit program examples, again, vacuum cleaning in the pre-stressed, precast concrete industry. The new OSHA silica specifically eliminates sweeping, blowdown, and shoveling of debris. And this industry has been doing it since the beginning of time when they remove concrete pieces from forms. A metal powder manufacturer around their presses had a terrible dust problem because of the tungsten carbide powders they were using, a known carcinogen. And they needed a vacuum cleaning system, otherwise they were going to have to put 25 people on respirators. And the associated cost of a respirator fit program, not to mention the facial hair problem. On the pneumatic conveying side, this picture is maybe not obvious from the outlook, but a manufacturer of wire and cable was applying a superabsorbent powder or superabsorbent polymer to the wire before they were putting the sheathing on the wire. This powder, superabsorbent powder, was not being captured well, and the operators in the area were getting super sensitized to it. Their eyes were drying out. The mucous membranes in their nose and their mouth was drying out, and they became so super sensitized to it that they couldn't work in the area. We developed a pneumatic conveying system to capture the dust at the source, filter it from the airstream, and then return the captured dust to the process. Confined space. These days, we're finding more customers interested in how they clean their equipment and how dirty is it to remove filters. The pictures show a pneumatic conveying system where you can remove the filters in the cleaner plant air. It's not an enclosed space. The cover swings out of the way, and this would be in contrast to the picture of the blue receiver on the right that has side access doors. So the top access filters eliminates a major confined space issue. Sustainability measures. This is where some of the greatest economics actually come in. Reclaiming lost products. In a production line, perhaps putting sesame seeds on a hamburger bun. The sesame seeds that don't stick to the bun previously were lost product. Using a pneumatic conveying system and specialized pickup bins, you can pick up, capture the lost sesame seeds and put them back into the process. Segregating metal powders from a grinding operation, you can increase the scrap value. Bakery waste from defrosting spiral freezers typically was washed down into the drain, into the wastewater, local wastewater treatment plant, at a customer who was getting back charged $10,000 a month for the high BOD content that they were putting down the drain. And also, a sustainability measure is to reduce the downtime or increase the uptime when cleaning machinery. Again, this is an internal goal. Any one of these subjects could be its own webinar. So I apologize if some of these were a little shorter than some might like, but we hope in the future we'll be expanding on these topics. And thank you for your time. Kevin, I'll hand it back to you.
Well, thanks, David. We're not going to let you get away quite yet, though. Excuse me. We have a number of questions. It's amazing how many different aspects there are to dust management. For our listeners, please type your questions for David in the Ask the Question box on the screen. We will get to as many as we can. Within a few days, this presentation will be available for on-demand viewing, and we'll post the archive on the Plant Engineering website and send you an email message with a link connecting directly to it. Now on to the questions. Jeremy Catron of Huber Engineering Woods had one very specific question he'd like to ask Dave, and I think you can handle it. What tools are effective to vacuum coarse wood particles or strands of wood without plugging the lines?
Great question. I guess defining coarse or strands, I can probably take a good guess at what that is, that it's not sawdust. So generally the rule for picking up something other than a powder is the largest particle or largest dimension of a particle is half of the diameter of a tube, of a conveying tube. Where that gets tricky is with products that are long, as in strands of wood or wood chips, wood larger than typical dust particles. If it is part of a process where it's being loaded, automated, or in large scale, then the conveying lines are going to be significantly large. Getting the material out at the destination is the next challenge, because those materials don't like to come out of conical shaped vessels. So depending on the rate and depending on where the material is being delivered, there are receivers, we call them tube hoppers, or straight-sided cones that can handle materials that don't come out of a cone-shaped vessel. But the size of the line it's hard to answer specifically. I would say the first thing you should do is send material to a conveying manufacturer, conveying equipment manufacturer, and have them test it. And try to duplicate the conditions as best possible to prove what works or doesn't. So I hope that's detailed enough.
Well, thanks, David. I'm sure it was for our present purposes. Another question. Pneumatic conveying systems that exhaust outside usually require an air permit. What is the typical emission factor in grains per dry cubic feet of air exhausted? And that's from ArigTech Environmental. Excuse me if I mispronounced that.
I will say I don't know the grains per dry cubic foot. It is common in our business that the primary filters on a conveying system or a vacuum cleaning system is rated 99.9% at 1 micron particle size. it is also typical that we have a secondary filter, which is a HEPA filter. And a HEPA filter is, by definition, is rated 99.97% at 0.3 of a micron. And that is common to recirculate that air back into the plant. It's not uncommon. Or if the vacuum producers are inside, the exhaust air is clean enough to stay inside the plant. In some northern climates, they want to keep the air in the plant. They don't want to exhaust it. But I'm afraid I don't have the grains per dry cubic foot of air. This is in a combustible dust environment. There are standards that talk about air material separators having to be outside in some cases, and you can't put the air back into the building unless it is HEPA filtered.
So thanks, David.
Sorry, I don't have that.
Well, thanks, David. Scott Hager of Kewanee Scientific Corporation asks, is it an issue if small screws and nails are occasionally picked up with a vacuum system? This would be for a wood dust application.
Yeah, if this is a vacuum cleaning application, then you're running a higher risk of creating a spark inside of the vacuum cleaning system. If it's a classic central vac where you're pulling it through a tubing network. So if this is something you can't avoid, then you can have anti-sparking product contact parts, which would be the tubing network, and possibly even the receiving section of the air material separator could be anti-sparking. But it is not, I would say it's not desirable. You can have magnets, assuming that these we're talking about ferrous nails and screws. You can put magnets in the system to try to separate them. But generally metal, this is why grinders are at high risk in a wood application, because they can let loose metal parts or sparks, and you just don't want that in a wood dust application.
Thanks, David. Dan at Zurichna asks, what type of vacuuming do you recommend for wood manufacturing?
What kind of vacuum do we recommend for wood manufacturing?
Yes.
Wood dust is very fine, but at a microscopic level, the dust actually looks like little Christmas trees or arrowheads. So filters that are smooth surface as opposed to cartridges tend to clean better of wood particles. On a portable level, air-powered vacuums work great because there's no heat source. There is, if they are appropriately labeled and listed for combustible dust environments, then everything will be static bonded and grounded. So we recommend that. I know some wood dust applications are monstrous volumes of material. So a larger system, a central system, may be preferred, but you do have to be careful that you're not pulling up that ferrous debris into a central system. Again, discharge at the end. You need to be able to get the material out of the system just as easily as you got it in.
Thanks, David. One of our readers, I know you mentioned during the presentation that OSHA was involved in guidelines for ergonomics design, but one of our readers asked, is there anything else you can tell us, other agencies involved in those guidelines?
Could you repeat the last part, Kevin, please?
Just whether there was other agency or regulatory bodies that were involved.
Well, I think, yeah, I mean, the Association of Safety, ASSE, and industrial hygienists, I think there are a lot of people who have best practices. Material handling professionals have best practices, but to my knowledge, there is not an ergonomic regulation, meaning other than OSHA coming in under the general duty clause. Everything else is recommended best practices.
Good. Thanks. A question here. One of our listeners asks, I have existing powder handling equipment and have never had any incidents with combustible dust. On the other hand, do I have a compliance problem?
You do have a compliance problem. This comes under the NFPA standards, which OSHA will enforce under its combustible dust national emphasis program. The NFPA standards are retroactive. There is no grandfathered permitted equipment under the NFPA standard. So if I could pick on the poster child for the combustible dust subject, which is Imperial Sugar, they didn't have an incident for 50 years. And then when they did have one, it was horrendous. So the fact that none have occurred in your plant so far just means you've been very fortunate. And you do need to do the process hazards analysis and the dust hazard analysis. But chances are existing central VACs, many dust collectors, and perhaps some pneumatic conveying equipment that exists may need to be replaced or upgraded for combustible dust standards.
Good. We have about 2 minutes, so I'd like to ask just a couple of last questions. If plant managers are trying to reduce plant noise levels, do you have any specific suggestions for them?
Yeah. One would be to look at the mechanical processes that are in the plant. We showed some pictures before of screw conveyors and belt conveyors. Replacing those devices with pneumatic conveyors will reduce the ambient noise level, unless of course you're moving rocks or nuts and bolts, which could be noisy. But in general, powdered products travel very quietly through tubing networks. The vacuum producers, which would be the source of some noise, can be placed outside. They can be placed in a mechanical room. They can be remotely located from the receiver and the conveying line. So those would be a couple. And of course, replace your shop vacs with good industrial vacuums.
That's right. Well, thanks, David. Final question. How do I convince management that an investment in compliance is a good business decision?
That's a good question. We mentioned before, if your operators are subject to potential for back injuries, there is a huge cost of a back injury. There are, again, the studies that said that the indirect costs may be 6 to 20 times more than the direct costs to a corporation. On the other hand, an OSHA study stated that for every dollar invested in a good, bona fide safety program, for every dollar invested, there was $4 to $6 worth of return, whether that was reduced premiums or reduced injuries. There are lots of business examples just avoiding compliance fines, avoiding those $12,000 fines from OSHA.
Good. Well, that concludes our question and answer session. Thanks for the great questions, and thanks again to our guest speaker, David Kennedy, for sharing his time and expertise. I'd also like to thank VAC-U-MAX for sponsoring today's webcast, and now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it as we use this information to improve our webcast. On behalf of Plant Engineering and CFE Media, thanks for attending, and goodbye.